AP Calc, back for part 3. Last part, I promise. So I wanted to do 23 in 2 different approaches. I'm going to do 25 and show you guys some things that we talked about from pre-calculus as well. And then 27 to end things up. So 23, I'm just going to solve it as is. I see division, I'm going for quotient rule. So K of V is equal to the bottom times the derivative of the top, which is going to be negative cosecant of x cotangent. And then I'm going to subtract, which I'm already out of room. Didn't plan this too well. How about I just say subtracting the top times the derivative of the bottom, which the bottom is going to be secant of x is secant tan. So let's try to keep them all v's, yeah? All of that's divided by the bottom squared. Yuck. So now I've got secant, cosecant, cotangent, and it's negative. Still don't have enough room. And then it'll be minus secant, cosecant, tangent. All of that divided by secant v squared. Now the question is, what kind of simplification can come from that? I guess they both share a secant, cosecant. Why don't we factor out a negative from both of those and then this as well? So negative secant of v, cosecant of v, and that's going to give us, it divides this out, so give me cotangent plus tangent. Still divided by secant squared of v. So I can take out a secant and maybe do some more stuff. I'm not sure. Well, we could just leave it at that. So I'm going to box this up with a question mark. Maybe simplified? I guess I could turn everybody into sines and cosines. But maybe that's not enough. Hey, how about we do the algebra first method on 23b? Yeah? Okay. Because this is just too much. So K of V is the same as, you know what, I'm going to rewrite this horizontally. Cosecant of V divided by secant of V. So that's 1 over sine divided by 1 over cosine. Keep, change, flip. Flip the second and multiply. Now reminding you, we have not actually taken a derivative of anything yet. This is still algebra first. Oh, cosine over sine. That's cotangent. What's the derivative of cotangent? Negative cosecant squared. Yes. No. Now what we can try to get down to that simplest cosecant squared v, maybe by moving some of these things around. I mean, I see, so that's negative 1 over sine of v times cosine of v over sine of v plus sine of v over cosine of v divided by, maybe we make this a fraction like that, divided by 1 over cosine. So I could distribute this, I'd get negative cosine of v over sine squared of v plus, these signs will cancel, so it's minus 1 over cosine. And then flip the second and multiply. Man, I did that twice now. Can you guys see that? You can barely see it. There you go. Cosine of v over 1. I guess we're going to keep going with this, huh? I know. I get going on these things and I just don't stop. Multiply it through, you get negative cosine squared over sine squared. And then you get, these cancel out. And that's a minus 1, because these canceled. All right, that's cotangent. And then, okay, pidentity. This is cosecant squared. Sorry, I keep switching to x's. I need to get over those x's. Okay, so you got this, which is the same as that. Whoa. But hopefully you guys can see that this is way more elegant and less time-consuming than this monstrosity here. Let's try 25. Okay, so different concept altogether. I wanted to remind you guys that there's this thing called even versus odd functions. We touched on it a little bit with the pre-calc review, but not so much with the trig. With trigonometry, when we graphed, you guys know how to do this. Remember when we graphed and you factored things out of it was kind of like the b term? It's the number that you use to get the period of the function. Well, bottom line is sine of x, sine of negative x, cosine of negative x, and all the other trig functions, they're either odd or even. Even functions, hold on, let me write first. All right, so odd functions are ones in which when you plug in a negative x for a normal x, it makes all the y values negative. So a negative x value makes the y value negative. That is a true statement for sine. And it's also true for tangent. It's also true for cosecant and cotangent. Cosine and secant are both even functions. They're the ones that, when you plug in a negative x, you still get a positive y. Anyway, 25 was reaching back to that pre-calc concept to just keep it fresh for you. So what you would do first is you'd say, I'm going to rewrite this as the negative sine of x plus cosine of x. That's just how it works. Then you can take your derivative. A negative sine would give me a negative cosine. A positive cosine would give me a derivative of negative sine. And that's it. All right, I got one more for you, then I'm done. Let's use this space. I think this is the Greek symbol phi. I'm going to commit to it. No x's. All phis. All right, so I hope you guys are thinking, let's multiply this out, kind of like you would a polynomial, because that's what I'm going to do. So algebra first. Cotangent times tangent, they're reciprocal identities, which means when you multiply them, you get 1. And then you get cotan times sine. So minus cotangent times sine. And then this is just cosecant. And then these are also reciprocal identities. So it's 1 and it's a minus. All right. So here's what I'm going to do. 1 minus 1 is 0. Negative cosine over sine times sine over 1. I just turn them all into sines and cosines because I could kind of see, hey, that sine's going to cancel out with that one. And then over here, I could try to do the same thing. This is 1 over sine times sine over cosine. Hey, that works. So this is negative cosine of phi plus 1 over cosine. Now I'm sure I could maybe explore this a little bit. I feel like I could find common denominators, get 1 minus cosine squared, which would be sine squared over cosine. I could do some stuff with that. But I could also just say this is secant, and we can be done with it. I'm going to say it's secant, and we're done with it. All right. Thank you for watching, and I'll see you later.